So those who are online are able to hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Ready or not? Right. Yes. Keep trying this problem. You guys keep trying this problem.
Okay, sir.
Ready? So let's discuss this problem. See, a force of 72 dyne is inclined to the horizontal at an angle of 60 degrees. Find the acceleration in a mass of 9 grams, which moves in the horizontal direction. So if you look at the diagram for this, let us say there is a block on which a force of 72 dyne is applied in such a way that this force is inclined at an angle 60 degrees with respect to the horizon. Now, this force can be resolved into two components. What are they? One is F cos 60 degrees, and the second is F sin 60 degrees. So, if you observe, this F cos 60 is the one which is causing the acceleration to the object in the horizontal direction. Right? So they are clearly mentioned, the object starts moving in the horizontal direction. What component of force is responsible for the motion of the object in the horizontal direction, that is F cos 60. So what I will do is, according to Newton's second law, I will write F is equal to mass into acceleration. But which force is causing the acceleration? It is F cos 60 is equal to mass of the object into acceleration that is taking place along the x direction. If I call this as x, then I write it as ax, and ax is what we have asked us. So F is 72. Time can basically be written as gram centimeter per second square, right? Into cos 60 is half is equal to mass of the object is 9 gram into acceleration of the object along x direction. So gram and gram will get cancelled. 2 will cancel 36 times, and 9 will cancel 36 times. So 4 centimeter per second square is going to be the acceleration of the object along the x direction. So this will be the required answer. Let us see. Now the next question is, a scooter is moving with a speed of 36 km per hour, sees a child standing in the middle of the road. He applies the brakes and brings the scooter to rest in 5 seconds, just in time to save child. Okay. Calculate the average retarding force on the vehicle if the mass of the vehicle and the driver put together is 300 kg. So let's try to take the data first. So when you look at the solution here, the speed, the initial speed of the motorist is given as 36 km per hour, right? So how to convert kilometer per hour to meter per second? You need to multiply this 5 divided by 18, right? Then kilometer per hour will get converted to meter per second. So this is going to give you 10 meter per second. So this is going to be the initial velocity. So remember, in problems, wherever brakes are being applied, the final velocity will mostly be 0. Because brakes are applied only with the intention to bring the object to rest. So when you do this, V will be equal to 0. So that's what they have mentioned also. Brakes are applied and the scooter had come to rest in 5 seconds, right? So what is going to be the time? Time will be equal to 5 seconds. And the total mass of the system is going to be equal to 300 kilograms. If this is the given data to us, our job is to find the average retarding force. Remember, the retarding force according to Newton's second law is again given as mass into acceleration. But in this case, the acceleration is going to be retardation basically. So when you calculate the retarding force, it is going to be mass into retardation. So mass is 300 into. To find the retardation, what I will do is I'll apply the formula V minus U divided by T. So this is what is acceleration. We know that V is equal to U plus AT. So A will be equal to V minus U divided by T. So this is going to be equal to 300 into final velocity is minus initial velocity is 10 divided by the time taken is 5 seconds. So this is going to be minus 600 Newton. So minus sign here indicates that the force is retarding in nature. The point here. Here. So proceed to the next problem. The next problem is a bus starts from rest accelerating uniformly. So here the acceleration is constant. So they're saying that the bus is accelerating and the initial velocity is 0. So if I start collecting the data, you will see and acceleration is given as 4 meters per second square. At time t is equal to 10 seconds, a stone at t is equal to 10 seconds, a stone is dropped out of a window of the bus, which is 2 meters high. Right? So let's say the bus is moving in this way. Okay. And from the ground at a height of 2 meters. So the bus is going in this way. Right? The bus is going like this. From certain height, the stone is dropped. Okay. Remember, if this is the stone, okay, had it been dropped when the bus is stationary, it would have traveled in a path like this, right? It would have traveled in the vertically downward direction. Whereas, if it is moving and it is dropped, then what will happen is it will start traveling in the backward direction. Because the object has the velocity in this direction, so when you drop it, what will happen is it will start traveling in the backward direction. It is no more going to be a straight line path, it is going to be a parabolic. Okay, so have this in your mind. So that is the scenario which is going to occur here. At t is equal to 10 seconds, the stone is dropped out of the window, which is at a height of 2 meters. What are the, so there are two questions that are asked. One is magnitude of the velocity, and second is acceleration of the stone at 10.2 seconds. Means exactly after 0.2 seconds from where it is dropped, they are asking what would be the acceleration. And in this scenario, you can take the value of g as 10 meters per second square. So here, so if you look at the scenario when the stone is dropped, right, it has a velocity in this direction, right? And what is the velocity of the stone? That we don't know. So let's say it is Vx. Okay. So when it is traveling in the downward direction, it has a velocity in the downward direction as well. So what will happen is this Vx and Vy put together with the particle parabolic. Is that point here? So they're asking what would be the magnitude of velocity. Means you need to find root of Vx square plus Vy square, because V vector in this case is going to be Vx I cap plus Vy j cap. So the magnitude of velocity in this scenario will be root of Vx square plus Vy square, and they're asking what is the value of this. Is that point clear? Right. So further, let us take the equations of motion into consideration. So if I take the equations of motion, the height of the object is, so the height at which the height from which the object is dropped is 2 meters. Is that right? So h is how much? So when I apply the equations of motion, it usually along x direction and y direction. See what is going to happen. So if I take Vx is equal to ux plus ax into t. Okay. So Vx is equal to ux plus ax into t, which implies Vx is equal to, what is the initial velocity of the object along the x direction? So it started from rest and it started accelerating at a speed of 4 meters per second. So if you take the first scenario from where it has started at rest and it has reached to some point after 10 seconds, right? So for that, if you apply the equation of motion, Vx is equal to ux plus ax into t. So what is going to be the final velocity at the point the stone was dropped? So Vx will be equal to ux is 0. Because along the horizontal it started with 0 velocity plus what is the acceleration along x direction? It is 4 into what is the time taken by the stone? It is 10. So it is going to be 40 meters per second. Means this scenario, at the time the stone was dropped, it was at 10 seconds. The bus had a horizontal velocity of 40 meters per second. So that will be the initial velocity for the next 2 seconds or next 0.2 seconds. Right? So I call this as Vx dash is equal to Ux dash plus Ax dash into T. So Vx dash will be equal to for the journey between 10 to 10.2 seconds. Right? What is the value of Ux dash? It is 40 plus what is the acceleration of the object? 4 into the time taken for the 10 to 10.2 seconds is 0.2. So it is going to be 40 plus 0.8 or 40.8 meter per second. Means after the 0.2 second, the stone will have a horizontal velocity of 40.8 meter per second. Right? In a similar way, if I apply the equation of motion along y direction, so I'll apply Vy square minus Uy square is equal to 2 into A by into S square. So if you see along the vertical direction, since the bus was moving horizontally, when it was dropped in the vertical direction, what is the initial velocity? Uy is 0 because the bus had velocity only in the horizontal direction. So when the stone was dropped in this direction, there was no velocity given. So they didn't drop it like this. They didn't push it like this. He just left it. So when he left it, it was only the horizontal velocity which is actually taking the parabolic path. Okay. Now if you see, if Uy is 0, then Vy square will be equal to 2 into acceleration along y direction. It's going to be g. Right? So if I take the downward direction to be positive. Sorry. So Vy square will be equal to 2 into acceleration along y direction is how much? G. So that is 10 into displacement along the y direction is. So here I took both of them to be positive because downward direction I assume to be positive. So if you take it as negative also there is no harm. This will be minus, this will be minus, both will get multiplied and will be same positive. So how much is the answer going to be here? It will be 40 meter square per second square. So remember Vx dash, so I call this as Vx dash. Okay. So Vx dash is going to be 40.8 meter per second and Vy square will be 40 meter square per second square. So what is going to be the speed of the vehicle? Sorry, speed of the stone. It will be root of 40.8 the whole square plus 40. So here I did square it because I already have a square value in mind. Right? So from this, if you calculate, that is going to be the value of magnitude of right, which is the speed basically. And if you see the next point, they are asking the magnitude of acceleration of the stone at 10.2 seconds. So if you want the magnitude of acceleration, remember acceleration along x direction is fixed, which is 4 meter per second square. Acceleration along y direction is also fixed, which is 10 meter per second square. So what is going to be the resultant? A will be equal to root of ax square plus ay square. So ax square is how much? 16 plus 100 is going to be root of 116 meter per second. This point here. So make a note of this. So did you all copy this? Done?
Yes, sir.
Let's try this one. So the sixth example is, there are forces of 5 √2 Newton and 6 √2 Newton which are acting on an object of mass 1000 kilogram at an angle 60 degrees from each other. First, let's try to visualize a diagrammatically. So there is the force of 5 √2 Newton and 6 √2 Newton acting at a point which are inclined with each other at an angle of 60 degrees. So someone is trying to pull the object in this way, the other one is pulling the object in the other way, so that the object will either move along my left hand direction or along my right hand direction. When we take the resultant of these two, means it will be somewhere in between. Okay. Now, this is acting on a particle whose mass is 1000 kilograms. Right? So first we need to find the acceleration and the distance covered, and thirdly we need to calculate the velocity of the mass after 10 seconds. So these three parameters have to be calculated. So how to proceed is very simple. So what we need to do, first find the resultant of these two forces. So how will you find it? By using the parallelogram law of vectors. Because when will you apply parallelogram? When both the vectors are acting at the same point. You apply parallelogram. If they are in continuous order, you will apply triangle. So in this scenario, we need to apply the parallelogram vectors. So if I take F to be the resultant, then F will be equal to root of, if I call this as F1, this as F2, it will be F1 square plus F2 square plus 2 F1 F2 cos theta. This is the resultant of whom? Of the parallelogram law of vectors. So root of a square plus b square plus 2ab cos theta, where theta is the angle between both the vectors. Right? So f will be equal to root of f1 square is 5 square into root 2 square. So it is actually 5 root 2 square, which will be 25 into 2. How much is that? It is going to be 15 plus f2 square is 6 square into root 2 square. So 6 square is 36, root 2 square is 2, 36 is going to give us 17. Plus 2 into 50 into 72 into cos of how much is the angle? It is 60 degrees. Correction. So root of f1 square plus f2 square plus 2 into f1 is 5 root 2, f2 is 6 root 2 into cos of 60 degrees. Right? This is going to be root of 112 plus 2 into 5 into 6 is 30 root 2 into root 2 is into cos 60, which is half and half will get cancelled. This will be root of 112 plus 60, or it is root of 172. Right. So the resultant of these two forces is going to give you root 172 Newton. Right. So with the help of this, I'll be able to find the acceleration. So what is the acceleration taking place in the horizontal direction, that is in this direction? That is along the direction of the resultant. So how much is it going to be? A will be equal to F by L, that will be root of 172 divided by M less 1000. So these many meter per second square will be the answer. That is with respect to the acceleration. Right? Next is distance. S will be equal to ut plus half at square. Right? So since I am assuming that these two forces are actually the responsible factors behind which the object is actually put into motion. I'm assuming that the object was initially at rest. So if it is initially at rest, I can ignore this parameter. Then I will say S will be equal to half into acceleration as root of 172 divided by 1000 multiplied with t square. So since they mentioned the time as 10 seconds, it is going to be 100. So 2 zeros and 3 also get cancelled. It will be root of 172 divided by 20. So these many meter. So this root 172 I'm leaving it to you. You have to find it out. What you can do the prime factorization and try to write it in the form of square roots. And the last point that we need to calculate this problem is velocity. So how to calculate the velocity? V is equal to u plus at. U is again 0. So V will be equal to acceleration was 172 divided by 1000 into the time is 10. So it will be 172 divided by 100 meter per second. So this is going to be the equivalence. This is point here. Make a note of it. Clear? Shall I proceed? So we do one last problem based on Newton's law. Then we'll go to the next one. So by now you should have understood that when you talk about the problems in Newton's laws of motion, you have most of the problem based on Newton's second. Right. Slowly we'll be doing problem based on Newton's third law. So Newton's first law doesn't have any problem because it's a statement. It says an object is going to be at a state of rest or in uniform motion unless you apply an external force. But the second and the third one can be mathematically represented. Second one, you apply the formula and the third one, you say sum of all the forces in one direction will be equal to sum of all the forces exactly in the opposite direction. Right? Based on this, you will do the next problem. So see, there is a block of metal which is weighing 2 kilograms, is resting on a frictionless plane. So let's assume that this is the metal block, right? It weighs 2 kilograms. It's resting on a frictionless plane. It is struck by a jet releasing water at a rate of 1 kilogram per second. If you look at the unit of it, right, it says the amount of mass that is coming out of the jet tube per second. So in 1 second, how much, what amount of water is getting released? 1 kilogram of water. That's the meaning of this, 1 kilogram per second. And this is happening at a speed of 5 meters per second. So try to understand. Here also you have something like rate. Here also you have rate. So what is the difference between both the rate? Here it is a rate of mass that is coming out. It is the rate at which it is able to cover the distance. That is the speed, right? So if this is the given scenario, calculate the initial acceleration of the ball. Meaning this very simple. What visualize. This block is lying calmly. What they're doing, they're taking a jet of water and trying to hit on top of this. So instead of you creating a direct impact on this, what they are trying to do is, with the help of water flows, they are trying to push this. If that is the scenario, then they are expecting us to calculate only the initial acceleration of the block. Means what would have been the velocity with which it has started, based on which you can calculate the acceleration. Initially, what was the velocity of it? See, it was at rest. That's what they mentioned. But finally, what is going to happen? It will attain some velocity like this. Right? It will suddenly start moving in this way. So when it starts moving in this manner, what is the acceleration it experiences at that instant is what we need to calculate. Is that point clear? So how do we see? You see, let's collect the data first. So this is the metal block. Let's say this is the spray or the jet of water that is actually coming out. So what is given? The amount of mass per unit second is given as 1 kilogram per second. Is it right? Now, delta P by, I'll make it as P. So delta M by delta T is 1 kilogram per second. And delta V by delta T, I will write it as, and delta V by delta T, I'll write it as 5 meter per second. Right? And what is the mass of it? The mass of the metal block is how much? Right? Proceed. So, I know that acceleration is equal to force divided by mass. Here, if you observe, this is the biggest part of this problem. So, force is exerted by the water. Mass is, which mass am I talking about? I'm trying to talk about the mass of the metal block. So, mass of the metal block is 2. So, in the denominator, I'll substitute 2, but how do I substitute the value of F? That is where I'm going to get stuck. So that is where we need to recollect the concept of Newton's second law. So what is Newton's second law state? Force is equal to the rate of change of linear momentum. So F is equal to delta P by delta T. No. So A will be equal to delta P by delta T, the whole divided by the mass that is experienced. Sorry, the mass of the object which is experiencing the force. Right? So what is delta V? So delta MV by delta T. Can I see? So delta M divided by delta T is given to us divided by the mass, call it as. So just to differentiate what I will I'll make the mass of the metal block as M dash so that you don't have any confusion. Can I do this? Right. So what is delta M by delta T? The rate at which the water is coming out is 1. Into the speed with which it is coming is 5 divided by what is going to be the value of M dash? That is 2. So what is going to be the answer? 2 0.5 meter per second square. If you observe the problem, it is actually similar. What do you think? You need to analyze the situation. So you check the answer once. Then you can copy. Got it? 0.5 meter per second square is what? Why do they give it as? Because the friction had come and fixed that in the base of F, you need to write it as force exerted by the jet minus the force exerted by the friction. Writing the data detail something values. That so now we'll go to the next concept. Now we'll go to the next concept called as impulse. So the next topic that we are going to discuss is called as impulse. Okay. So till now, if you see, we were discussing different concepts like linear momentum, and we try to connect that linear momentum to the concept of Newton's second law. So how did we do that? Newton's second law is defined as the rate of change of linear momentum. Right? So this momentum has something to do with different parameters associated with the structure. Right? So now I'll come to the point. Let's try to connect the dots. Suppose, let's say this is a brick. Okay. So let's say this brick is placed in a support like this, where here it is followed. Let's say it is placed in this way. Right. So you have seen certain stunts where the brick is actually hit. Yes. So it is kept like this, and they hit it, and they break it. Right. So if you see, they don't randomly do it. Suppose I ask you to do the same thing, you do it with the wrong technique, first thing you will break your hand. So you need certain technique associated. Has anyone done that in what your hand fracture? No. Okay. Better not learn the technique and then. Okay. Suppose you keep it like this. Let's say I'll just show. I'm not going to break this, don't worry. I'm just showing a demonstration. So if I bring my hand, so what am I doing? Initially my hand is free. So it is a rest. If I bring it fast and hit it, right? Do you think it will break? So I'm doing like this. Assume that there is a brick. The color is also matching. Assume that there is a brick. If I bring it and keep my hand like this, do you think the brick will break? What is your guess? I'm keeping my hand like this. Do you think brick will break? No. Right. Maybe you will find some cracks here. I can write and give you the break is wet. First thing that you break is your hand. Okay. And write and give you. You try and see. I've done that. I've broken also. Because better don't. Okay. So if I bring, okay, what am I actually doing in terms of physics? What am I doing? In terms of physics, so initially it is addressed. My hand has some mass. So I'm actually changing the momentum. Am I doing it or not? Right? I'm actually trying to change the momentum of my hand and I'm trying to transfer the momentum that is associated with my hand to this object. So when I do that, it is experiencing some amount of transition. What the transition will be? Particles inside are disturbed for sure. Right? But what you're doing is, if you try to bring and keep your hand in contact, you're actually creating a force on the object where you're not trying to change the force on the object with respect to time. Why? Because just before it strike, the momentum was 0. As soon as it strike, the momentum would have been certain non-zero value. But what are you doing? After it has strike also, after the hand has struck the brick also, you're still trying to keep the momentum at the same value by keeping your hand in contact. So your momentum didn't change. Whatever impact you create, you're going to keep it at the same value. Whereas, if I take my hand and see the way I'm going to follow, see the pattern. If I hit like this, I'll take. I'm just touch and take. Okay, right and give it a break. So inner force is there. Just touch and take it and break. Because in the previous scenario, what you try to do is you applied force. But in this scenario, what you try to do is you applied impulse basically means a large amount of force, I repeat it, a large amount of force exerted for a short duration of time. Touch and take. So you're actually applying large force, but for a short duration of time. And this is what you call it as impulse, right? To keeping this example aside, can you give me some more examples where this impulse is applicable? I can't see how one of it is. Not visualized. Anything that you see with your eyes. Slap also force you. Not touch like this. There is slap it. It's slap it. Yeah. So that's what karate is. They give impulse only, they don't give force. You can think of carom board. So what happens with the carom board? You have a striker, it goes and hits the point. So striker is not in contact with the point for a longer duration. So it is applying a force, and that force is getting applied on the object for a shorter duration. Means they both are in contact with each other only for a short duration. Similar is the case with respect to cricket. Table tennis. So wherever a ball and a bat are coming in contact, everything is pulsable. Like how many of you play badminton? What physics is involved behind that? That is when you go to buy a racket. Okay. How to buy a racket. What mass is supposed to be there, what should be the shape. Never thought of that. We'll discuss in center of the study. So what is the string doing there? So if you see the columns, right? Is it in contact with the net for a longer duration or less? Less, right? So next time when you play, right, don't go like this and keep hitting it fast. Just stand at the place and just try to give it an impulse and see how fast it goes. You have to know to get back. Very bad. And that's smashing. Okay. So next time you try this, when it comes, right, just touch it and see, and you come and give me a feedback. I do it every day. So that's the sign action. So all those things are impulses. Are you able to understand? So coming back to the subject, what is impulses? We try to visualize everywhere we apply it. But what is this impulse all about? If I have to give a book definition or simply in terms of the statement to it, what do I call it as? Large force exerted on an object for a very short duration.
So when bullet strikes objects, just don't be on the object for a long time. Just
That's not called impulse.
that's
If you say, yeah, that is also right, provided the object is actually scattering in pieces.
like a blast.
So large force exerted on object for a short duration. Has anyone got this kind of problem? You go to you use what different box you take? The steel box, suppose. That circular one, you take it, sir. Have you ever seen it getting stuck?
Yes.
What do you think?
So
Without your knowledge of the English, physics will be put here. To keep the box to the wall, just hit it like this. You can see it will come in a second. Because what you're doing is, when you click it right, you're actually making use of the elastic property of that steel. It gets compressed slightly at the top so that the cap becomes loose. So it can't withstand the moment of bed. You don't go and hit on the cap. It will not open. Cap, what is it? You will make it even more tight. You'll never get it out. Okay. So hit it at the bottom. So these type of movements, where do you see? So this is elastic motion. So there what I told you. So you take the box and just hit it and hit. Okay. If I had the box, I would. It comes. That also. So these are all the examples. Okay. So large force exerted on an object for a very short duration is what we call it as impulse. Right? So let us look at the mathematical parameter. So impulse is generally represented with symbol J. So J is equal to, if external, I can write it as, generally write it as dt, but here you can write it as delta t. Where the delta t is actually a very small value of it. Okay. Are you able to understand this? Now, if I have to write this J for an instantaneous value, then I write it as integral of f external into dt. Where the time interval is very small. So I can write it like this. Are you able to understand?
so is that a
Directly. The definition large force exerted on object for short duration. Force into time is what it is. Right. So here if you observe, J is equal to external force multiplied with delta T. But what is external force? It is rate of change of linear momentum according to Newton's second law. And you multiply it with delta T. So delta T and delta T will get cancelled. So J will be equal to delta T. So what is the meaning of this? If force is defined as the rate of change of linear momentum, then impulse is defined as only change of linear momentum. There is no rate. Delta T is gone. So force is defined as the rate of change of linear momentum, and impulse is defined as only change in linear momentum. Okay. So this is the reason why the objects are behaving in that. You're actually changing the direction of it. So that's why next time when you how many of you see cricket? Here also. How many of you play? But you won't watch. So generally, what do they do for fast bowlers? Do they give any effort? When they want to drive, they'll just try to hit it like this and take it. Observe. Okay, when they do that, actually what is happening? The ball is coming towards the bat with certain amount of momentum. And when they drive it, right, when it is driven, the change in momentum is taking place at that instant. So if you calculate the change in momentum taking place at that instant, that is the impulse created by the bat on the. So that's how it works.
If the ball is very fast, if you just give
Just touch it again. Because what property are they actually trying to explore? Because momentum. Ball is having greater momentum. It has a mass. So when a fast bowler bowls it, what happens? It has a greater velocity also. So can I say it has greater momentum? So in the greater momentum, if you change the value just by touching it, okay, the impulse will be. So that's why if you see fast bowlers case, they don't take much effort. So, no front foot, nothing. Not have time much. Right?
that's chances that chances you can just put a sum of that.
That is see how where the stump is the balls or the pass balls. So if the runner hitting near the keeper, you know who is shy about that. One watches with the pass. Because you are taking DT, want to eliminate the DT. So wherever you use P, differential coefficient, you need to integrate. When you use delta, you generally don't take it because deltas are mostly used for average values and the D is used for instantaneous values. Is that clear? They'll give you the problem. So you will take the limits of T. So you take it from T1 to T2. So it is understood, that is why it is written. So whichever is the coefficient, according to, so whichever is the differential coefficient, limits will be taken for that value. Since here it is dp, limits are taken for time. Are you able to understand? Here. So J will be equal to delta V. Now if you see what is going to be the SI unit of it. So what is the SI unit of linear momentum? So if I use F external into delta T, force is measured in terms of Newton and time is measured in terms of second. So Newton second is the unit of impulse. Or if I use J is equal to delta V is measured in kilogram meter per second. Or kilogram meter per second is also going to be the unit for impulse. Is the point clear? That is how it goes. Suppose there is a graph given for force as a function of time. So force is given as a function of time, and let's say there is a graph like this. Okay. Where this limit I'll call it as T1. This limit I'll call it as T2. If you find the area under this force and time graph, this also gives you impulse. You understand? Because whenever you have a physical quantity which is the product of x-axis and y-axis, you generally find area. If it is a ratio of y-axis and x-axis, you find the slope. These are the two logics. Okay. So here F into time is the product. So for you to find the impulse, you always need to find the area under the graph. For example, if the formula had been F divided by delta t, then I should have found the slope. But here, what is it? I need to concentrate only on area because it is product. Are you guys able to understand? Yes. Shall we proceed? With the concept. So based on this, we will try some. Only thing is you need to be good with the resolution of it. For another problem. You are here with what is the difference. Write down the next heading as conservation of linear units. Because you have angular also. So conservation of linear moment. Okay. So this concept is very simple. What do you generally mean by conservation? Conservation is you preserve something, you save it for the future, right? Or to put it in simple terms, any parameter that does not have a change associated with it is said to be conserved. Are you able to understand? So here, what am I trying to say? I'm saying that there is a physical quantity called linear momentum, which is conserved, means which is preserved and not changing with respect to time. So when is this going to happen? Right. So even before I try to define it, I'm trying to apply the logic next. So what am I saying? I'm saying that the linear momentum is always a constant, means final linear momentum is equal to the initial linear momentum. Can I say this? So from this, can I say P final minus P initial P0? This is another way of writing. But what is P final minus P initial called as? Can I call it as delta P? So delta P is 0, right? So if delta P is 0 or P final minus P initial is 0 or if P final is equal to P initial, everything represents the fact that the linear momentum is conserved, right? But what I'm going to do is, I'll make this delta P and I will divide it with delta T on both the sides. If I do that, delta P divided by delta T is equal to 0 is the required condition for you to have the linear momentum to be conserved. But what does delta P by delta T represent? It represents the external force. So when the external force, I repeat it, when the external force acting on the system is 0, right? What can you say? Linear momentum is said to be conserved. And that is going to be the statement for conservation of linear momentum. What is the statement here? When external force acting on the system is 0. What do we say? Linear momentum is said to be conserved. Done. So based on this, try to solve this. Throughout the formula that we are going to use, I already discussed. Impulse is equal to force into time, or is also equal to change in linear momentum. So J will be equal to F into T, which is M into V minus Q. Or J vector is also written as integral of T1 to T2 F vector dot dt, which is the area under the force time graph. It is not FF, it is FT. FT graph. Okay. So velocity u and v are in meter per second, mass is in kilogram, time is in second, and force is in Newton, and impulse is measured in Newton second or kilogram meter per second. I think we have discussed all these parameters, right? In that one page. Yeah, that's right. Okay. So based on this, first example, look at it. So there is a batsman hits back a ball straight in the direction of bowler without changing its initial speed of 12 meter per second. If the mass of the ball is 0.15 kilogram, determine the impulse imparted to the ball. Okay. So let's say this is the bat. Okay. So this is the bat. Let's as of now, let's say the bat is kept straight. Then you can hit it directly. So if the incline right, you actually change the direction, about which we'll see later. So the bat is vertical like this, the ball has come, and the ball is set back to the bowler itself. In which direction? In the same direction. That's what they mentioned. In the direction of bowler without changing its initial speed. So if this is the ball, let's say mass of the ball is m, and let's say it is approaching the batsman with speed v. So this is before collision. Then after collision, what will happen is it will and travel back to the opposite. Is that right? So this is going to be M and this is U. The point here, right? Now if you see, determine the impulse imparted to the ball. So for you to calculate the impulse, you need two parameters. You need either force and time, or you just need the initial and the final moment. So in this case, what you have the initial and the final moments. What you will do is you will calculate the impulse as change in linear momentum, which is written as. So if I take the rightward direction as possible, then the left minus mu. Okay, right, the next step, try to understand. M into V final minus M into V initial. Okay. So M into V final, if you see, M into V final is in this direction, that is minus 2. Minus M into V initial is in this direction, that is U. So how much will be the answer? V minus 2. Separate. And this is going to be the impulse that is imparted. So J will be equal to minus of 2 into M is 0.15 into U is, well, so how much will be the answer? 24 into 15 divided by 100. Right. So calculate that value. Those many kilogram meter per second or Newton second is going to be the required answer. I have to visualize. Eight point six. Minus is okay. So minus 8.6. So magnitude wise, you can make it as 8.6 kilogram meter per second. Should I proceed? Minus 6. Next one is cricket ball of mass 150 grams moving with the velocity of 15 meters per second is brought to rest by a player in 0.05 seconds. Okay, so look at the duration, it's a very short duration. Now, calculate the impulse and the average force exerted by the player. So if you look at the data that is given, right distribution, mass of the object is 150 grams, so 150 into 10 power minus 3 kilogram, or I can write it as 0.15 kilogram. So velocity, initial velocity of the object is 15 meters per second, final velocity of the object is 0. Right? How much is the time taken for this kind of a scenario? 0.05 second. So what is going to be the impulse here? So J is equal to change in momentum delta V, which will be M into V final minus M into V initial. So M is 0.15 into V final is 0 minus V initial is 0. Right? So 0.15 into 15 is going to be 2.25 kilogram meter per second. Okay. Next is the average force. So force, I can write it as impulse divided by time. So J is equal to F into delta T. Is that right? So J will be equal to F into delta T. So F will be equal to J divided by delta T. So J is how much? 2.25 divided by delta t is how much? 0.05. So I can write it as 225 divided by 5. How much will be the answer? 50. Is it 50? Sorry. It's going to be 45. So it's 45. Like this. So the last problem. So there is a rubber ball of mass 50 gram. So there is a ball of mass 50 gram, which falls from a height of 1 meter. So let's say 100 centimeter. The ball is dropped, and it goes fixed and rebounds to a height of 0.5 meter. So from where is it dropped? It is dropped from a height of 1 meter. After hitting, how high is it facing? Exactly half of the initial level. Right? It is rebounding. So where do you think? Why is it only rebounding to half of the level? Any ideas? When will it be able to rebound to the same height?
So when we just
Or to put it in simple terms, if the energy is transferred, what is happening? I know it is out of context, but just trying to explain it to you. Initially, it had potential energy. So initially, it had potential energy. When it was dropped, its potential energy decreased and got converted to kinetic energy. After it hit the floor, potential energy becomes zero, and the kinetic energy again started decreasing. So potential energy increased when it was time to come up. Potential energy decreased and potential energy increased and the kinetic energy was decreased. Okay, but coming back to this concept, let's try to visualize what is happening when it is dropped from a certain height. It is attaining velocity in the downward direction. Here, the velocity is zero because it is dropped. When it is hitting the floor, what would have been the velocity it would have attained that we need to calculate? So that velocity before collision. So after it has hit, it has raised to a certain extent. We need to calculate what is the velocity after collision. If you calculate the rate, if you calculate the change in momentum that has taken place, then you will get the impulse. If you multiply, if you divide that impulse with 0.1 second, you're going to get the average force. Okay, let's visualize the situation again. This is the ground. Height is 1 meter. So it starts traveling in the downward direction. What is the velocity before collision? For us to calculate the initial, for example, here u is 0. Okay. So v square minus u square is equal to 2 into ax. So v initial square minus in this journey from A to B. So in the downward journey, initial velocity was 0. And the final velocity, the velocity just before it has collided with the ground, is equal to 2 into acceleration of the object in the downward direction is 10. Or I write it as g for the time being into displacement of the object is 1 meter. So here it is going to be S. So vi square will be equal to 2 into 10 into 1. So it is going to be 20 meter square per second square. So what is going to be the initial velocity? Root 20 is actually 2 root 5. 2 root 5 meter per second. Let this be equation number 1. So after collision, what is happening? After collision, the object is having initial velocity in the upward direction. Okay, where I call this initial velocity as the final velocity after the collision. So try to understand, this is the initial velocity required for the object to race in the upward direction, but the initial velocity is obtained by the object only because of collision. So the velocity, the initial velocity that is attained after collision, I am calling it as Vf. So that I will be able to calculate the change in momentum. Okay, so V square minus U square is equal to 2 into A. Okay, small correction. I'll call this as UF. Okay, let me call this velocity as U. Okay, so V final square minus U final square is equal to 2 into acceleration into displacement. That is in case number 2. So when the object has traveled from B to C, this height is how much it is going to be? 0.5 meters. Is that right? So V final square is 0, because when the object has traveled from here to here, at point C the final velocity is going to be 0 minus what is the initial velocity? That's what we need to calculate. So UF square is equal to 2 into acceleration of the object is still in the downward direction, which is going to be minus G into displacement of the object is in upward direction, which will be plus S, that is going to be 0.5. So minus UF square is equal to 2 into minus 10 into half. So 2 and 2 will get cancelled, which implies UF square is equal to 10 meters square per second square, or UF is going to be equal to 10 meter per second. So for us to calculate the impulse, what do we need to do? Impulse will be equal to change in momentum, mass of the object into final velocity is 10 minus initial velocity is 2 root 5. Is that right? Right. So these many meters per second is going to be the impulse. So for you to calculate the average force, what I supposed to do? Average force will be equal to impulse divided by 0.1 second. So this value, take this value and substitute it here and divide it by 0. That will give you 15 required volts. Is the point clear? Make a note of this. Because both are in downward direction. I, G and S. So if you want to take minus, put minus here and minus here. Okay. So you can actually break it according to the scenario and also, right? Not necessary that every time downward direction should be taken. Okay. But if you observe it clearly, right? For this scenario, I have taken downward direction to be positive. For this scenario, I have taken downward to be negative. But I was very particular with one thing. If I took downward as negative, I took the upward as positive. That is why this minus and this minus got cancelled, or else what would have happened? Had you taken this as plus, you would have got minus UF square is equal to minus 10. Sorry, minus UF square is equal to 10. So square of a value can't be negative. That means clear. So be careful. Those who are online, you can leave.
Thank you, sir.